Okay, welcome to this video on difficult factorising problems. So first of all, when we're asked to factorise an expression, we're taking something that's given with various terms added or subtracted, and we're turning it into something that's made of a series of multiplications of its factors. Okay, so let's look at the first one. Now you might recognize this as the difference of two squares. Okay, but you should also recognize first that there is a common factor of 4 in both terms. So if I was answering this question, I would begin by recognizing that factor of 4 and rewriting it as 4 lots of 9a squared minus b squared. Okay, now it's still the difference of two squares because 9a squared and b squared are square numbers. So I now need to split that bracket up into a pair like this, 3a minus b and 3a plus b. Okay, so that's quite easily a GCSE question that you could get. If you multiply that out, you would get back to this expression here. Okay, the next one is a cubic expression because the highest power of x is x cubed. But what is significant here is before we start to factorize out the whole thing, we should take out any common factor we see all the way through. And not only is each term even with a common factor of 2, but also each term has a common factor of x. So if we take out 2x, we're left with a quadratic that says x squared minus, now that will be 4x and minus 5. Now, it may be the case that that quadratic didn't factorize, in which case that would be as far as you could go with your factorization. But this does factorize because you're looking for the factors of minus 5 that add up to give you negative 4. So what you're going to do is you're going to see that that's x minus 5 and x plus 1. Okay, and again, if you multiply that out using FOIL, you will get back to this expression here. So the first two are fairly straightforward GCSE type questions. Now it's starting to get a little bit more difficult because you now have a combination of x and y terms, sometimes on their own and sometimes with the other. So one approach to this is to take one of the letters and substitute it with 1. And this helps you build it up. So I'm going to consider this instead, which is 8x squared minus 2x times 1, basically, replacing the y with 1, and then minus 1 squared, which is minus 1, okay, because you're squaring the 1, not the minus sign as well. All right. Now, if I were to factorize that should be quite easy. It's a quadratic. To get the minus 2 in the middle, it's going to have to come from brackets that begin with 4x and 2x. Okay, the minus 1 can only come from minus 1 and plus 1. All right, so which is which? Well, we need to have a minus 2x, so the minus 1 has to multiply with the 4x, and then the plus 1 has to multiply with the 2x. So if you multiplied that pair of brackets out, you would go back to this expression here. But we don't have the 1, we have this y instead, and y squared. So we just need to make an adjustment, and in this case it's quite simple. So our actual expression was this, 2xy and minus y squared. So what we need to do is come over here and see how that changes things, and it should be quite easy to see that in this case we replace the 1 back with the y. Okay, and you can check that out and see that by multiplying that out, you do indeed go back to this expression here. Okay, so that's the answer to the first 3. So certainly these 2 are GCSE questions. That one right at the top end GCSE, going into the sort of further maths level. Question 4. This one is a little bit more tricky because we have higher powers of P and Q in this case. So we'll take the idea that one of the variables will set to 1 again. So I'm going to set Q to 1. And I'm going to rewrite it like this. So the expression becomes 10p to the power 4 minus 13p squared minus 3. Okay, because q to the 6 and q to the 3 are both 1 if q is set to 1. Now we could even take that a little bit further and just imagine that we substitute let p equal, or p squared equal t, for example. Then we could see that this is a quadratic in t because it's 10t squared, okay, minus 13t plus minus 3, okay, and then we could factorize it in the normal way, okay, and that would give us this. Now you've got to get a minus 13 from this, and it's going to come from 5 times 3 minus 2, okay, or rather minus 5 times 3 plus 2. And a little bit of experimenting would quickly get you that. So I'm going to put 5t and 2t as my factors of 10t squared. Okay, and I'm going to put, well, I'm going to need the minus 3 to go with the 5 to give me the minus 15. And I'm going to need plus 1 there. Okay, now I could go back and replace the t with p squared again, but it's easier to see it like that as a quadratic when you haven't got these higher powers in. Now, let's just return then to that. So it's 5p squared, okay, instead of 5t, plus 1 and 2p squared minus 3. Okay, now if we go back to our original expression, we need to get our q back into it. And so if you look at what we've done, we've replaced the q with 1. So it should be easy to see that the original expression, which was 10p to the 4 minus 13p squared q cubed minus 3q to the 6. Okay, based on what we've just done, is going to be 5p squared plus q3 plus q squared, or q cubed rather, multiplied by 2p squared minus 3q cubed. Okay, now if you multiplied that back out, you would see that it would indeed give you this expression here. Okay, so a little bit more tricky, that one, and certainly beyond GCSE. Okay, now more difficult to come. So let's look at this one. Slightly unusual and a slightly different approach to this one, number 5. So what we do here is we could multiply everything out first. So get rid of all the brackets, regroup everything, and then have another go at factorising from scratch. Sometimes that will work easily, other times it could take a long time because you could be creating a more difficult problem. In this case, I notice that if I look at the first part here, I actually have in that bit there the difference of two squares. So I'm going to write the whole expression as 3 minus x times 3 plus x. Okay, first, and then for the second part, from here onwards, I'm just going to copy that out. Because now what I've got is a common factor of 3 minus x in the two terms that I've created. Okay, there's a 3 minus x and there's one in there. So if I take that out of both terms, I just write what's left. And what's left from here is 3 plus x. Okay, and what's left from here, which I would now be adding on because of this add sign here, is 2x plus 9. Okay, now you might want to put brackets around the 3x and the 2x plus 9, but you don't actually need them because you're multiplying the 3 minus x with the sum of those two terms. So that gives you a simplified expression of 3 minus x times 3x plus 12. And you might think, well, that's it's fully factorized. But in combining those two terms in the last bracket, those four terms rather, into two, we've created a new common factor. And the common factor in here is 3. So we've got 3 lots of x plus 4. All right. So that can actually be summarized or finished off by writing it as 3 lots of 3 minus x times a third of this bracket, which is now going to be x plus 4. And that's the question 5 completed. Okay, so that was using a little trick really to recognize that we have already partially factorized it, and that saves us a bit of time. Okay, question 6. Now this one is quite a difficult question. So what I'm going to do is just make a bit more space by scrolling that up to there. Okay, so let's have a look at how we're going to approach this one. We can actually make a substitution for n to be the number 1 again, and that does simplify the problem a little bit for us. But before we do any of that, we must recognize that there's a common factor all the way through, in this case of 5 and also m squared. So the first thing I'm going to do is to write this as 5m squared. Okay, and then open a bracket and take that factor out of all the terms. So it's going to leave me with 16 m squared n, okay, plus 2m minus n, and finally minus 8m n squared. Okay, now of course it's possible that having taken that factor of 5m squared out, that there's no further factorization possible. But in fact there is, and if you were asked to factorize something like this fully, you would be looking for opportunities to simplify this further. So I'm going to take the same approach that I did with in these earlier examples, where I considered making n equal to 1 temporarily, okay, just to simplify the problem. Now if we did that, we would still have our 5m squared, okay, but the quadratic that would follow would be in terms of m, and it would be much easier to work with because we're going to have this. The n is now 1, so it's minus 1, and this is just going to be 8m here, minus 8m. Now what we've done is we've created two like terms now that we need to combine. So in fact we should rewrite that as 5m squared, 16m squared, and it's going to be plus 2m minus 8m, which is minus 6m and minus 1. Now you should be familiar enough with factorising a quadratic like this. Okay, it shouldn't take long to see that it would become 5m squared. The 16 would need splitting into 8m and 2m, because that will give us the difference of 6 that we're going to need for the middle term. It's got to end in a minus 1 and a plus 1, so this will be the minus 1 and this will be the plus 1, and it's easy to check that out just by multiplying those two brackets together. So that's how it would look if n was actually equal to 1. But what we've got to do is go back to our original expression here, and we've got to try and match this up and see which of these ones we need to change back into n. Okay, and sometimes it's just going to take a little bit of inspection and trial and improvement, but there are a few things we can do. For example, to give us our m squared n term, we're going to have an n either with the 8m or the 2m. So we need to turn one of those two terms so that they have an n with them. So it's either 8mn and 2m or 8m and 2mn in order to give us this 16m squared n, you see. But we also know that we need to have a single term of plus 2m, and that can only come from 2m times 1, which we've already got. So we don't want to tamper with this 2m. So the suggestion is that the 8m needs to have the n attached to it. So let's just see what that would look like. Okay, so it's 8mn plus 1. Okay, now that can't be plus n, because if it was, there would be another factor of n to take out. So it's that. This has got to now be 2m. And in order to get our minus n term, we've got a 1 and we've got to multiply it by minus n, which makes that the minus n there. And that is the correct answer. Now, if you check that out by multiplying those brackets together, then timesing the whole lot by 5m squared, you will go back to this original expression. Certainly a difficult question. So once we had finished with our substitution of 1, we were looking for places where we could return the 1 to being an n again. So there's an imaginary 1 sitting next to any of these terms, isn't there? 8m times 1 is the same as 8m. And it's that 1 that was next to the m that we turned back into an n. Right? Quite a difficult question, that one, for sure. And you certainly wouldn't be getting that on a GCSE paper, but that could appear in your further maths. So make sure you work through that and make sure you understand it. Okay, hope that was helpful.